Hi, welcome back to our lesson. And this lesson we are going to look at redox titration. Redox titration is where reduction and oxidation take place simultaneously. It's hence redox reaction or titration. Titration where redox reaction do not require indicators because the color of some of the reagent change when their oxidation state changes. Example, dichromate 6 ions are orange in color. When reduced to chromium 3 ions, the solution becomes green. So they don't need an indicator. In potassium permanganate 7 and potassium dichromate 6, permanganate ions are purple in color. When reduced to manganese 2, the solution becomes colorless. Manganese, we have purple, and then manganese 2 are colorless. Determination of water of crystallization. So we have ammonium iron 2 sulfate crystal having the following formula. This is a formula, very simple, don't worry about the size of the formula. What we need to determine is N, the water of crystallization. 8.0 gram of salt was weighed accurately and dissolved in 50 centimeters cubed of 2.0 molarity of sulfuric acid. The resulting solution was made up to 200 with distilled water. Pipette 25 of this solution and pour it into a conical flask. It was then titrated this against a 0.02 molarity acidified potassium permanganate 7 until the solution became colorless. The average volume of 0.02 moles of potassium permanganate solution used was 20 centimeters cubed. Calculate the number of moles of potassium permanganate that reacted. 2. Using the following ionic equation, determine the number of moles of iron 2 salt in 25 centimeters cubed of the solution used. And this is the reaction. 3. Determine the molarity of iron 2 salt solution. 4. Determine the relative formula mass of this salt. 5. Determine the value of N in the formula. 6. Write the formula of ammonium 2 sulfate salt. And here is the solution. In such questions, I would advise you first of all to read every sentence slowly to internalize and understand. It's a very simple question, and if you read carefully, you'll get all the answers correct. So for example, in question 1, calculate the number of moles of potassium permanganate that reacted. Very simple. What do we know? The average volume of this was 20. So what's the meaning of 0.2 m? It means 0.2 moles in 1,000. So what about in 20? So 0.02 moles in 1,000. What about in 20 centimeters cubed? Cross multiplication, you get the number of moles as 0.0004 moles of potassium permanganate. 2. Using the following ionic equation, determine the number of moles of iron 2 salt in 25 centimeters cubed of the solution used. So we have been given the ionic equation. It means here we have 1 mole, here we have 8 moles, here 1 mole, 5 moles, and here we have 4 moles. So that is the reacting ratios. So therefore, what is the question? It is about the number of moles of iron. So where do we find iron in this ionic equation? Oh, they are here. So if this is a question, and we know the number of moles of manganese, which is here in 2, then we place it there. So now, and you know the ratios, so you just multiply this one with 8 to get that one, this one you multiply by 1 to get that one, 0.004 moles you multiply by that to get this number of moles. So 0.002 moles of iron 2 salt in 25 of the solution. The number of moles is that one. Now let's proceed to the next question. Determine the molarity of iron 2 salt in the solution. Molarity, remember, it is the number of moles in 1,000. Number of moles in 1,000. So what do we know about the iron 2 salt? We have 0.02 moles in 25. Okay, so we ask ourselves, what about now in 200? So this one, remember, they were in 200 centimeters cubed. So we first of all establish the number of moles. So these are the number of moles in 200, and to get the molarity, then it will be 200 centimeters cubed as this number of moles that we got here. Then we ask ourselves, what about in 1,000 centimeters cubed, because molarity is always in 1,000. So we do a cross multiplication to get 0.08 m of the salt. Number 4, determine the relative formula mass of the salt. In the salt, we have 200 centimeters cubed contained 8 grams of salt. Meaning what? In 200 we have 8 grams. So what about in 1,000? We got the molarity and we got the value to be 40 grams. So this is the mass in, but we have been given the molarity. We calculated the molarity and found that the molarity was 0.08 m and has a mass of 40. So what about in 1 mole? So 1 mole will be 1 multiplied by 40, we divide by this. This is the molarity which was there in 1,000, but we know that this number of moles had this mass by doing this calculation. Therefore, the relative formula mass will be 500 grams of the salt. 5, determine the value of N in the formula. So we have 500 as the relative formula mass. So what about now the value of N? We do this computation. Nitrogen has 14 as RAM, hydrogen 4, sulfur, oxygen, iron, again we have sulfur, then we have oxygen here, and here we have the water. So this one will give you 500. So when you sum up all that, you get 284 plus 18n is equals to 500. You subtract both sides 284 to get 216 and 18n. So our n is 12. And finally, write the formula of ammonium iron 2 sulfate salt will be that way, and our 12 there. So that is then how we do redox titration, and this one we have used in determining the value of the water of crystallization. Here is a quiz for you. The quiz is also provided at the end of this video or below the video in the notes section or the quiz section. Work out and you'll get the answers. In the second part of the quiz, here are the answers. Read carefully, read the instruction carefully, and you'll get all the answers. Redox is very simple. continuation of the questions. That's all. Thank you. Bye bye, and let's meet in the next lesson.